Let's have intercepts. The definition: an x-intercept which is denoted by the rectangular coordinate a0 is a point where the graph crosses or touches the x-axis. A y-intercept denoted by the rectangular coordinate 0b is the point where the graph intersects the y-axis. When the rectangular coordinate a0 is an x-intercept, we may say that A is an x-intercept. Similarly, if the rectangular coordinate or the point 0b is a y-intercept, we may also say that B is a y-intercept. Example: given the equation x equals y squared minus 1, determine the x and y intercepts. So let's have first the x-intercept. To determine the x-intercept of this equation, we are to let y equals 0. Okay, and then we solve for x. Okay, so we have the equation. It's x Okay, if we let y equal 0, so x is equal to negative 1. That means the x-intercept is the point negative 1, 0. Or simply, negative 1 is the x-intercept. Meaning, the graph of this equation x equals y squared minus 1 intersects the x-axis at point negative 1, 0. So if we have this say graph, Cartesian plane, okay, so that is negative 1 and 0. So this is the x-intercept, negative 1, 0. Now, to determine the y-intercept, we let x equals 0 and then solve for y. Okay, so we have the equation x equals y squared minus 1. So x becomes 0, so we have, and then we have y squared is equal to positive 1. Okay, and then we get the square root of both sides of the equation to solve for y. So we have y is equal to plus minus square root of 1 is 1. Therefore, the y-intercepts are the point 0, our x, 0 minus 1, and 0 plus 1, or 0 and positive 1. So if we are to plot this on the Cartesian plane, so the graph of this equation intersects the y-axis at point 0 and negative 1. So say this is negative 1, therefore, and this 0 and negative 1, and the other one is 0 and positive 1. So these two are the y-intercepts. Okay. If we are to sketch the graph of the equation, its graph look like this. It's a parabola open into the right. Notice that this graph or this equation or this relation is not a function. Okay? It's not a function. What makes it not a function? Take note, dito pa lang sa y-intercept, this x value equals 0 takes more than one value. Okay, more than one value in the y-axis or in the range. So 0 is paired with -1 and at the same time 0 is paired with +1. Therefore, this violates the definition of function. But still, it's a relation. However, though this relation is not a function, pwede pa din siyang matawag na function. However, we are to, what's that? Pwede natin siyang i-consider as a combination of several functions. Okay? Halimbawa, itong sa taas, from this point, okay, itong graph na to, the graph of this equation above x-axis is actually a function, right? It's a function. Kasi 1-to-1 yan. There's a 1-to-1 relationship. At yung nasa baba, yung graph ng equation below the x-axis is also a function. Kasi it satisfies the definition of function. But taking the whole picture, the whole graph of the equation, it's not a function. Okay, actually, itong sa taas, the equation for this graph above the x-axis is y is equal to the positive square root of, that's the positive square root of x plus 1. Okay, if we are to sketch the graph of this equation, okay, ito yung graph niya, yung graph above the x-axis, and it's a function. Yung sa baba naman, the equation is y is equal to negative square root of x plus 1, and it's a function. Okay, this is a function. But again, sabi ko nga, pag tinake mo siya as a whole, hindi na siya function. Okay? Actually, these two are called implicit functions. Okay? Either way, how did we get this y equals square root of x plus 1? Galing yan dito sa ating equation. Okay? We have x equals y square minus 1 solving for y. We have y square is equal to x plus 1. Getting the square root of both sides of the equation, we get y equals plus minus the square root of x plus 1. Okay? Let's have horizontal and vertical asymptotes. We have the definition. A vertical asymptote is a vertical line x equals a, which is a limiting line for the curve. As the values of x approaches a from either side, the value of y increases or decreases without bound. The vertical asymptote is the vertical line x equals a. Similarly, a horizontal asymptote is a horizontal line y equals b, which is a limiting line for the curve. As the values of y approaches b from either side, the value of x increases or decreases without bound. Let's have example. Find the asymptotes of the equation x squared times the quantity y squared plus 1 equals 4. So let's start with the horizontal asymptote. Okay. Okay. So for horizontal asymptote, we are actually concerned with the horizontal line, which is y is equal to b. Okay, so y is equal to b, and where this b is a constant, a real number. Okay, so we will solve for x in terms of y. So that's our step. Solve for x in terms of y. So we have the equation x squared times y squared plus 1 equals 4. Okay, so we solve for x in terms of y. So we get multiplying both sides of the equation by the expression y over y squared plus 1 over y squared plus 1. We get so this will be cancelled or eliminated. So we have x squared on the left side of the equation, and we have 4 over y squared plus 1. Okay, then we get the square root of both sides of the equation. We get x is equal to square root of, that is square root of 4 and square root of 4 over y squared plus 1, that is plus minus 2 over square root of y squared plus 1. So this is our equation in x in terms of y. Now, what value of b, as y approaches b from either sides of b, meaning if meron tayo ditong constant na b, y approaches this b from the left and y approaches this b from the right. Okay, so meron bang what's that? Meron bang limiting value of this y? So do we have a limiting value b for this equation? Actually, we do not have a limiting value for this. Why? Because our denominator, which is this expression square root of y squared plus 1, will never become 0 for any values of y. Okay, remember that b is one of the many values of y. Okay, so we do not have a limiting value b. I'm referring to that limiting value b. We do not have a limiting value b for y that will make the denominator 0. Okay, meaning x is defined and is real for all values of y. So for example, if y is a negative number, negative real number, the denominator is still positive. If y is a positive, it's still positive. If y is equal to 0, the denominator is still positive. And so x is defined and is real for all values of y. Meaning to say, we do not have a horizontal asymptote for this equation. Okay, so that's it with horizontal asymptote. Now, how about for vertical asymptote? Okay, so similar with horizontal asymptote, we are interested in the vertical line x equals a. Okay, so we solve for y in terms of x. Okay, we solve for y in terms of x, and so we have the equation x squared times the quantity y squared plus 1 equals 4. So solve for y in terms of x. How are we going to do that? Okay, so we multiply both sides of the equation by 1 over x squared, y the expression 1 over x squared to get rid of this, and so we have y squared plus 1, and then we have 4 over x squared, and then use subtraction property of equality. So we have y squared equals 4 over x squared minus 1, and then get the square root of both sides of the equation. We get y is equal to the square root of that's minus square root of, okay, we simplify the terms in the radicand. So we have x squared 4, and the numerator is 4 minus x squared. And so we have the equation for y in terms of x. Do we have a limiting value a? Okay. Ito yung tinutukoy na limiting value. A is the limiting value of x. Meaning, as x approaches this limiting value, this constant a, y increases without bound or y decreases without bound. Do we have a limiting value for this? Yes, we have. X should not be equal to 0. X should not be equal to 0. Why? Because as x approaches 0 from either side, okay, meaning we have this 0, and then say this is the real number x's, okay, so as this x's approaches 0 from the left and approaches 0 from the right, our y either increases without bound or y decreases without bound. And y increases or y decreases without bound for this x equals 0, meaning our vertical asymptote is the equation of the line x equals 0. This is our vertical asymptote. Okay. So again, for this example, we do not have a horizontal asymptote because x is defined and is real for all values of y in the real numbers. For vertical asymptote, y is not defined and is not real, okay, for x equals 0, that is why this equation of the line x equals 0 is our vertical asymptote. But y is defined and is real for all x in the real numbers except 0.